Welcome, P99 conference attendees. My name is Kathy Jory, and I'm here with my colleague from Zadida, Roman Shaposhnik. And we're going to talk about our work in RISC-V architecture boards to try to make them useful as edge servers. So by way of introduction, I'll say that Roman is one of those rare geniuses, developers who probably stood out as a young guy at Sun Microsystems and continued to mentor and provide the next generation of developers with the tools they need to succeed. So if you're working with him, you're super lucky. He's also on the board of the Apache Software Foundation and co-founded Zadida, is the chief hacking officer there and strategy guru, all around good guy. In comparison, I'm a double E, so I seek out software as a tool, make it easier. That's why I like working with Roman. But I've also been around the block. I'm leading Zadida's developer program, so contact me, email me if you're interested. And basically, I like to, I've worked for decades in open source software, and I've seen the advantages that it has across my career. We're going to talk about, first, I'm just going to give you a brief overview of RISC-V next, which is that RISC-V, the RISC instruction set has been used in academia for quite a while. And in the early 2010s, I'd say at Berkeley, under David Patterson, Yensep Lee, Kirsta, some other grad students developed the RISC-V architecture that's now being used in industry because it was spun out first. Sci-Fi, they founded a company. You can see a timeline there where the foundation with other industries and universities was put together. And then companies got on board. And there's a lot of advantages to an open chip design, as you can imagine, with open software. One of them, for example, Western Digital came in and put a lot of funding into Sci-Fi. I talked to their CTO at the time. It was because, they're in the peripheral device business and they really wanted more common interfaces, to know what the software designs and the APIs were going to be up front. So a lot of advantages there. If you go to the next slide, you can see first they started with the microcontroller chipset, but the server class is just now starting to come out, like the BeagleBoard beta. What I notice, or what excites me a lot about RISC-V, is the Upstream Linux kernel capability. So if you have a chip design that's already known, then in parallel, you can be upstreaming and getting your changes to the kernel even before the chip's taped out. And in contrast, I spent half a dozen years at Qualcomm Atheros. I was part of Atheros when we got acquired by Qualcomm Atheros. We had to dip the MIPS kernels cores and take in the ARM ones from Qualcomm, and they would hand us a kernel, which was just basically a million lines of patched kernel of Android changes, and then we had to throw away modems and graphics and add networking and Wi-Fi radios for routers, and then turn it into, an OpenWRT SDK. And it was a lot of work. They would throw the kernel over the fence to Linaro to do the upstreaming, but it was after the fact. And it just takes a lot of time and effort, and it's much more of a maintenance burden all around when you don't have that capability. So, it's when we have all these niche customizations that are possible with RISC-V, you always want your software to be right there and ready to go. When the hardware comes out, the last thing you want is a brand new board, right, Roman, that you can't write software to. So having all the designs and the cores being open is great. So Roman, why don't you tell us more about the software?
Yeah, so that's actually the most exciting bit. And first of all, thank you, Katie, for such an amazing introduction. So next time I'll introduce you so I can also talk about how awesome you are. But this time I'll just talk about the software. So there's actually bad news and good news in software. So I'll start, as usual, with the bad news. And the bad news for this software lately has been that hardware monoculture is tough. And what I mean by the hardware monoculture is, honestly, let's face it, x86 architecture is extremely dominant, right? And when people tell me like, well, but what about ARM? And we have all of these, ARM servers and, we have Android. What I tell them, it's like, look, especially in this audience, like for this conference, we're talking about server side, right? And the server side, the easiest way to tell what hardware is the most prevalent one is to go to Docker Hub and just see what containers are available for what architecture. Actually, all of you should do that just to kind of like internalize the message that x86 is still the king of the hill. Now, outside of x86, and okay, even maybe ARM, right? Okay, I'll give that ARM is still, somewhat available nowadays on Docker Hub. Pretty much nothing else matters, right? We used to have open power. I mean, we still do to some extent, and it's still alive, right? But I think the community has largely moved on. And, I'm not even talking about things like MIPS and, some of the smaller architectures. So roughly it is x86, and it is, sometimes ARM, but most of the time it is x86, and that's why I call it a hardware monoculture. And again, all of you attending this conference, you are probably in business of optimizing your own software. So again, just ask yourself, what hardware are you optimizing it for? Chances are it's not just x86, it's actually Intel-based x86. So you probably don't even pay that much attention to AMD. I mean, sometimes you do, but most of the times it's a very specific monoculture-like, hardware landscape. And it used to be that just porting Unix or, AKA C was, sort of enough, no longer enough, because we have all of these other amazing language ecosystems. And finally, long way back, ARM thought that maybe we don't have to rely on the community as much. Maybe we can just pay people to port all of that amazing software. And Linaro got created, but that didn't really work out as well. So the key takeaway from here is the community is super important, but also being smart is very important. Which actually brings me to good news. So good news is that we kind of evolved from understanding an operating system as this centralized place which needs to be given to us from the gods above, like Red Hat or in my day Sun Microsystems. We kind of evolved into this cloud native architecture, which basically means that everything is a container, your infrastructure is immutable, and container orchestration platform manages the lifecycle of just about everything. Which, by the way, means that if your software, and I really mean like anything from ScyllaDB to anything else, doesn't really fall into that pattern, you probably should rethink how you develop and deploy your software. But again, most of the world has moved to cloud native types of deployments, and everything else by now, big statement, but I'm still going to make it, is sort of considered legacy. We're also in an era of specialized operating systems, and that is sort of in support of the cloud native architecture, because if you want to run cloud native well, it is not enough to have a container orchestration platform, let's say Kubernetes. You actually have to have a specialized operating system to run it on, right? And one of the first ones on the market was CoreOS. Even before that, although not all that well known, is Joyent's SmartOS, but CoreOS was sort of based on Linux. That's why it's more well known. I mean, Chrome OS is sort of in that same category. Obviously, every single cloud provider like AWS, GCP, Azure has actually host operating systems that we don't even get to see, and those are also these types of specialized OSs. And there's one particular open source one that is actually super exciting. Well, for one, because Katie and I work on it, called EvoS, that I will be actually giving you as an example today. So an OS is no longer a gigantic integration point. You don't have to make your package available for Red Hat or SUSE. You can actually package your software as a bunch of containers. Now for that, you actually have to have a container-based operating system, something like Alpine, which I also will be talking about. And then you need to run your bunch of your containers on top of some kind of specialized operating system. This is my strategy of how we can actually eat this RISC-V elephant one bite at a time. Because we don't have to do the change the world type of integration. We can just do cloud native plus specialized operating systems. So let me actually start with one example of a specialized operating system. And this is, again, just to kind of give you a sense that whatever software you're working on, you don't really have to be stuck at the level of thinking it's like, oh, I got to integrate with systemd because I need to run on, Red Hat, right? That is no longer the case. That is, in fact, probably a bad way of running your software anyway. So EvoS was actually developed for the edge computing, and it was one of the first, maybe the first one, open source, fully open source, fully community-driven operating system for the edge computing. And when I say edge computing, what I typically mean is computers that are just out there, right? So on this slide, we have, some of the edge gateways hooked up to machines, power plants, moving vehicles, that is what edge is to me. Unfortunately, edge means a lot of things, to a lot of different people. So given that we're working very closely with Linux Foundation, we actually had to come up with this, kind of like deconfusing white paper called Edge Taxonomy, which I actually highly recommend you guys download, and kind of classify all these different edges. But what's important here is that RISC-V is basically applicable to all of it. Now, EVOS for now is focused on the two, which is smart device edge and on-prem data center edge. And I will not go into details, just kind of like painting the bigger picture here. But my bigger point is, even if you're working on a piece of software that needs to run in a more of a traditional data center, kind of like a regional edge, or maybe even like completely traditional data center, RISC-V will come. Like servers are really coming. And I think EVOS might actually be the vector through which you might have a much better chance of moving your software into a RISC-V based data center. But for now, we're just looking at the edge, and that is basically because edge is available. And again, I will talk a little bit about what kind of hardware you can actually get your hands on, today, but it's all is edge hardware. Now, before I do that, let me actually just kind of like very briefly introduce you to what is EVOS. Now, EVOS, like I said, is a specialized operating system, and you don't even think about it as an operating system, because what it is an appliance type of an operating system that is based on hardware virtualization. So we effectively use either Zen, KVM, or Acorn. Now, obviously, on RISC-V, for now, we are only focused and limited by KVM, but Zen work on RISC-V is actually happening, believe it or not. There's a very active community of people hacking on it. And then, that boots. So like EVOS actually boots, right after your BIOS or UEFI is done. And it runs, domains. So some of these domains are control domains. And again, there are no notions of like traditional operating system things like usernames and passwords. So EVOS is fully controlled by what we call Eve controller. And Eve controller is effectively giving EVOS, a set of instructions of what to do next, which effectively translates into either starting new domains. And in this picture, you can see that one of the domains that can get started is a Kubernetes domain. We prefer K3s because it's small, and again, we're still sort of focused on the edge, but we can effectively run any distribution of Kubernetes. And typically, you would basically be looking in some kind of a legacy application like Windows 10, when EVOS runs on x86, but even sometimes on ARM. The good news about RISC-V is that there's virtually no legacy, so you don't actually have to worry about it. And then, EVOS itself is very small. So, one partition, we use partition A and partition B for updates, kind of like what Android or CoreOS does. So single partition is 250 megabytes. Both partitions are, half a gig. Eve also asks for half a gig of memory and 1 core of CPU, and you're off to the races, right?
Yeah, you could actually start with that previous slide, because what I wanted to do was set the picture of, myself. Like before coming to Zadita, I liked to live at the edge because, and at the edge only, like my smart home runs on a Raspberry Pi and it's only in my home and there's no cloud component at all, right? But that's sort of an impractical thing for industry to do, to have all these edges independently and autonomously running. So you can go to the next slide. So what industry needs to do is they have to take these things that can autonomously run at the edge, but how do you get your data to the cloud? And all these, sort of maker, professional, hobbyist ways of getting data to the cloud tend not to be secure, tend not to be, the best ways of doing things from a scalability perspective. And so what EVOS allows you to do is you deploy applications to the edge, but there's a controller element. So EVOS itself isn't really anything unless there's a controller that says what applications have you deployed to it. And it makes it scalable such that you run the edge as if it's part of your cloud. So, I'm fairly new to cloud infrastructure and managing all that, but now I see the value from managing deployed nodes in the thousands is from a DevOps perspective, from someone running the software, and this is what we're collecting the data, or we're processing the data, or we're getting all this metadata. I, as a DevOps person, don't know where it's running. I don't know if this app's running at the edge, if it's running in a data center, if it's running on an on-prem other server, and I don't have to care. And so again, the controller makes that core secure conduit with EVOS and nothing else outside of that core conduit until it's under the security of the cloud umbrella services.
Exactly. That's how we achieve the scalability. Absolutely. But let's actually talk a little bit about how we've built it, right? So EVOS is obviously driven by a controller, and you have to operate on the controller itself, and you do it sort of the same way that you would do on any public cloud. What's under the hood, though, is Alpine Linux. Now, again, why did we pick Alpine? Well, first of all, because it's the basis for most of the modern cloud-native workloads, and because the other modern OS is actually not really good for that. That's why people pick Alpine. So Alpine is just enough OS for any occasion, right? It is an immutable infrastructure, and honestly, the packages are just glorified tarballs, right? That's what makes it so easy to port it to a new architecture like RISC-V. And I actually highly recommend you check it out. So if you have issues with a traditional operating system, integrating your software, even if you're not doing cloud native, just check out Alpine, because it actually might be much easier to integrate your software with Alpine first, get it going on the board, and have fun with it. Alpine actually updates the software really, really quickly. So fresh ports are served really daily. And on the edge today, we actually have, there's actually the release of Alpine called Edge. On the edge of Alpine, we actually have RISC-V support, pretty much fully done. That's how quickly we give customers, new updates. Alpine also has good taste in the components that it selects. For example, it uses muscle libc as opposed to GNU libc. It uses, BusyBox userland, no nonsense init system, and it just makes it very compact and small, allowing you to do more things with your software as opposed to imposing the view of how the operating system needs to be designed. Alpine is not obsessed by the cross-compilation, but it's actually still very easily bootstrappable. So RISC-V port, I actually did the initial phase of it, was a pleasant surprise. I mean, it was basically, I ran it all in QEMU. And you can actually do it as well, even if you don't have your hardware yet, although, again, the hardware is pretty easy to get these days. And there's actually an awesome selection of entry points from container rootfs all the way to no-nonsense hardware bootstrap and iPXE boot. So all of those artifacts can be given to you from a single kind of like a build script that Alpine uses, which is a plain shell. It's a very nicely written shell. It's very easy to hack. So again, Alpine actually feels a lot more like a set of tools that you're using than an operating system that a vendor gave you. So that's why we picked it. Now, how do we leverage Alpine to build EVOS? Well, we're picking a lot of packages from Alpine, just wholesale, because honestly, Alpine packages, are to Linux what Maven Central is to Java these days. And whenever I need, a new piece of software, updated piece of software, I actually typically go to Alpine packages. You can just Google it, and then, just look for my package. And a lot of times it's actually a much newer version or much better updated version, than what a vendor like Red Hat, would give me. Alpine packages are composed, inside of OCI container images. That's how we actually leverage, the Alpine packages. You don't have to do that. But if you check out the Eve build scripts, you will see how that is done. All of the Eve builds are published as OCI container images. So that's one additional layer of indirection that we have over Alpine. We're leveraging LinuxKit and Containerd heavily. And again, both of these components allow us to compose the infrastructure and create those domains that I was talking about, but at the same time, have the flexibility of running just what we need. So again, a given container doesn't actually have to be based on Alpine. If your software is incompatible with Alpine today, you can run your Red Hat container, in EVOS. That's fine. That's actually the beauty of cloud native, because containers completely separate you from the host OS. Now, again, just a quick, few notes on porting to RISC-V. We started, as Katie said, with BeagleBoard beta from Star5, which is unfortunately nowadays is discontinued. Then the second board came. There is Nazure from Allwinner that is still very much available today, and you can actually buy it from AliExpress. And the porting was nice, but then the default image, immediately froze in the systemd during the execution phase. But then the Alpine was actually kind of cool. Because once it got ported, we got all the packages needed for the EVOS. We got Alpine running on BeagleBoard and Nazure. And now you can actually pull Alpine Edge Docker OCI image and get Alpine on your own laptop. In fact, if you're doing it on Mac OS, it will just work out of the box because QEMU user is set up. You can preset QEMU user, for x65 on your Linux as well, and that would just give you a development environment for RISC-V right away. A few packages still require work. That's where we need help. Things like basic technology like lib-unwind, but also Postgres and atomics, right? Which actually kind of brings me to key takeaway. I think, if you take anything from the presentation today, it is that the RISC-V is no longer about QM. You can buy an SBC today, and it's a very, very impressive SBC. It is basically a Raspberry Pi class. You can start hacking today. It will be very interesting to see how RISC-V displays ARM. This may be a presentation in and of itself, so I'm not going to go into details, but my mind is clearly on RISC-V. I think, RISC-V is very nice and open, so you can actually change the ISA, and you can actually bring things like, synchronization primitives and memory infrastructure, to the ISA. So if you're struggling with things like, lock-free algorithms, and, you're kind of like asking yourself, can I actually have additional, CPU instructions? Yes, with RISC-V, you absolutely can. Again, wholesale porting of the entire open source ecosystem is absolutely not going to happen overnight, but we actually have better ways of doing it. And finally, just bring your project. Talk to us. We have experience. Stop by our Slack channel, which actually brings us to the key links that I thought Katie would introduce.
Yeah, so here you're on the slide with, again, just to remind everyone, Project Eve and EveOS is available under the Linux Foundation. So you'll find at any one of these entry points and links, you'll find information about EveOS, the wikis, the calendars. You can join us on weekly calls, join the mailing list. We have a Slack channel, multiple Slack channels actually, for LF Edge. And then the GitHub is filled with great README documentation. Thank you very much, Roman. And you can pull Eve from Docker and install it on all sorts of different hardware. So again, thank you all for joining us today. We have our email addresses on this last slide and our Twitter feeds. So thanks, Roman. Thanks, P99 conference team.
Thank you, everyone, and see you.